So let's move on to the other reason why you might want to use Unreal 4 to make a visual novel. Now before we begin, I'd like to make a sort of, not necessarily correction, because this technically is viable, but a sort of comment on the last video. Because I was rushing to finish the video, I said that we could just make a boolean to say if the player won or not, but that's not really a great idea because then you would have to make a boolean for everything else, and we have a triggered flags variable. So instead of creating a boolean here, we would just say in our triggered flags if the player won or not. So back in our Dialog BP, instead of setting 1, we can get our game instance and get the triggered flags and add a value. The index value of this select would be this select over here because this returns if the player won or not. And then off this true, we would have to make literal name. The value could be something like player 1. And then off this false, we would also make a literal name, whose value is something like player lost or something. Also, I'd like to apologize for taking so long to make this video. The original plan was to either recreate one of the backgrounds over here in 3D so you could see the difference, or it was to create a steampunk environment so that you could see gears rotating in the background and actually, connecting to each other and rotating like gears would. And there would be steam everywhere with particle effects flying around, and it would be great. But it turns out that if you don't use a skill like 3D modeling for years, you lose the ability to do that. So I've been spending the last few days trying to relearn how to 3D model because I want to make my own assets for the next video series I want to do. Anyways, back to the actual tutorial. Now, you may remember in the saving and loading video that we could use a screen capture 2D to sort of project an image onto a render target. And then we could use that render target as our background if we want. So that's exactly what we're going to be doing, but we're going to be making our own scene capture 2D actor because this one isn't very useful for our purposes. So what do I mean by that? Well, you'll notice that even though the scene capture looks like it has a camera, it doesn't actually have a camera. You don't see a preview down here. If we were to drag a camera into the world, for example, you'll see that we have a preview to show what exactly this camera is looking at. It is possible to get a sort of mini preview of what our scene capture is looking at. If we were to right click, go to materials and textures, create a render target, we'll call this 3D scene 1 or something like that. Click on our scene capture 2D and change our texture target to be that 3D scene 1. You'll see that this thumbnail appears and it's really small, but you can sort of see what it's looking at. Also, if you wait a little bit, the preview in your thumbnails will also update to show what it looks like now. We could increase the size of it by going to our view options and changing the scale to be, well, all the way up. And you can sort of see it, but it's not great. And if you double click on it, you actually don't see anything at all, which is very sort of strange. I'm not sure why you don't see anything when you double click on it. It would be really great if you could, but you can't. In addition, we're not going to want these pixels to be 1 by 1, because otherwise these pixels are going to be stretched on screen, which obviously isn't very good. So we're going to want a size X of something like 1920 by 1080. And when you do that, the render target will have to update the scene. So if you just move it around a little, it will update the preview, and you'll see that it's stretched over here, and it's stretched over in your preview. And that is because it is stretching it to be in a square. The resolution is still a 16 by 9 resolution, but it's squeezing it down into a 1 by 1 square, so that's why it looks stretched, which makes it even worse for previews. And that's why we're going to be creating our own scene capture 2D so that we can actually see the preview in our bottom left or wherever you want to put it. Now, you might be thinking at this point, well, okay, so now we're just going to create a new render target for every single 3D view, but that would be kind of a pain, especially if you have a lot of 3D views you want to look at. So instead, what we're going to do is create these at runtime. So let's just delete this render target, and let's actually make our own scene capture actor now. So back in our content browser, I'm going to right click, create a new blueprint class. It's going to be an actor, and the name is going to be something like VN Scene Capture 2D. Go into our blueprint, and we're going to add a component, and the component of course is going to be our scene capture 2D component. And then we're going to add another component, and this is going to be a camera. And the reason we're adding a camera is so that we can actually see what our scene capture 2D is going to be looking at. So if we were to delete our scene capture 2D and the camera that we already have in here, and we drag in a VN scene capture 2D, you'll see that we still have the scene capture right here, and we can modify its texture target, but we also have a camera attached to it, so we have a preview to see what it's looking at. Now, if you wanted to modify a part of your scene, like this sphere for example, you'd have to click on the sphere and it would lose the camera's focus. So you wouldn't be able to see where the sphere is being moved through this camera's perspective. So what you can do is click back on your scene capture and click on this pin preview button down here. and it will pin this to your view. So now we can click on the sphere and we can move it around, and you'll see that it updates in your camera's view and it stays there, so you can do whatever you want. You can even rotate your camera around, and this pin preview is still going to be here. You can also have multiple cameras if we just Alt click and drag off one of these transform handles, for example, and you can have multiple previews, and you can pin them both if you wish. And now you will see that the sphere updates through both these views, which makes it very handy for when you want to use, well, 3D backgrounds in your visual novel. So now that we can see what our scene capture is looking at, we need to actually give it a render target. So in our scene capture 2D's event graph on begin play, let's right click and say create render target. We can give it a width and a height, just make sure this is 16:9. And what you could do is in your options menu, give the player a resolution option for how big they want their render targets to be, because the bigger these numbers are, the less performant they are going to be. But I'm just going to be lazy about this, and I'm going to say 1920 by 1080. So now that we have our render target, we need to get our scene capture component 2D and set the target texture. And let's test to see if this actually works. If we go back to our viewport hit play and go down to our VN Scene Capture 2D and click on the Scene Capture Component 2D, scroll down, you'll see that we have a texture target here, and it is the correct size. It is 1920 by 1080. And in the preview you can see what it is looking at, and it looks like it is looking at the right things. If we were to go to the other one, scroll down, you'll see that it also looks like it is looking at the right things, and it is the right resolution, so that's working fine and dandy. So now that our scene captures are projecting an image onto a render target, we need to somehow pass that render target onto our dialog widget, because right now our dialog widget can't change its background based on that image because it doesn't have access. So the easiest way to do this, in my opinion, would be to modify our VN game mode. And before we show our game/menu widget, what we're going to do is get all of our capture components. So let's do a sequence node first. Our den1 is going to connect to our show game/menu widget, and then our den0 is going to get all of our VN scene capture 2Ds and save them in a container. Now the reason I say container instead of an array is because we're not going to be using an array. Because if we only had it in an array, then our dialog could get our game mode, but then it would have to go through every single one of the scene captures in our array to find the one we're looking for. So what we're going to store it in is a dictionary. And we obviously need a key for that dictionary. So back in our VN Scene Capture 2D, I'm going to make a new variable. This is going to be a name, and I'm just going to call this our background name. Also, make sure that it is instance editable by clicking either this I or this check mark. And if we compile this, go back to our map and click on one of our scene captures, you'll see we now have a field we can edit called background name, and we can name this whatever we want. So this one is going to be called our left view, and the other one is going to be called our right view. And back in our game mode, what we're going to do is get all actors of class, and that class of course is going to be our VN Scene Capture 2D. Then we have to go through each of these, so do a for each loop, and then we have to add that to our map, which we haven't created yet. So let's create a new variable. We'll call this our VN Scene Captures. The type is going to be a name because that's going to be the key. We're going to change this to be a dictionary, and the value is going to be a VN Scene Capture 2D. So now in our loop body, we are going to get the background name from our array element and add that to our VN Scene Captures. So get our VN Scene Captures, add. The key is going to be our background name, and the value is going to be our array element. Now you might be thinking, why don't we just make the value of our dictionary the actual texture render target 2D object reference that we created? Because that's what we're going to be showing to our player as the background, right? But that's not true. Let me show you what would happen if we were to try to use this. So I'm going to create a temporary render target just to demonstrate this. Let's just call this temp. And let's make sure that this actually has an image so that you know that it's not the fact that it doesn't have an image as the problem. So you'll see that this has an image now. And if we go back to our dialog in the designer, if we go to our background image, change the image to be our temp, you'll see that nothing happens. Well, something did happen, but it's not what we expected. It doesn't show this temp over here. And what it's showing is our animation progress bar. If we were to make this not visible, you'll see that this is just invisible now. The background isn't showing up. And that is because our widget can't directly show our render targets for some reason. I'm actually not sure why. You might be thinking, well, what if we use a canvas render target? Because that sounds like something we could, put on the screen. It's called canvas after all. But that also doesn't work. If we were to create a new material and canvas render target, make sure that it actually is our canvas render target here. So this canvas render target has an image. Go back to our dialog and change it from temp to our new canvas render target 2D. It still doesn't show up. So we really just can't use render targets directly as our image. So what we need to do instead is create a new material that is going to be set in our background image, because this actually can take in a material as well. So let's go back to our content browser, right click, create a new material. This is going to be called our scene capture material. And inside of our material, we are going to want to do a couple of things. Right now it thinks that it's just going to be used as a material on an object. You'll see that we have our options for our base color, metallic, specular, which you never really touch, roughness, emissive color, etc. But that's not what we really want for our background image. We want this to be a UI thing. So over in the material domain, change this from surface to user interface. And now you'll see we only have our final color and screen position, which I never actually touch. The final color, of course, is going to be what the image looks like. So what we need to do is right click and say add a new texture parameter. And when we hit enter, we create a new parameter, and we can call this whatever we want. I'm going to go with view target, and we just need to pass this white pen into the final color. And you see that it has a default image of this sort of ugly muddy looking thing. That's not what's actually going to show up though, so don't worry about it. So we have to apply this and then save. And now back in our VN Scene Capture 2D, after we create our target texture, we are going to create a material instance. And if you don't know, a dynamic material instance is just an instance of this material, except you can alter anything that is a parameter. So back in our scene capture mat, we made a texture parameter, so now we can set this when we create our material instance here. So we need to choose the parent first off. That is going to be our scene capture mat. That is going to be what this material instance is based off of. And then we need to set texture parameter value. Now the parameter name is going to be whatever you named your input over here. So for me that was view target. So in our scene capture 2D, change the parameter name to view target. And then the value is going to be whatever that texture actually is. So that is going to be our target texture. So now that we have this done, we can actually start working with our dialog widget. So I'm going to change this image back to something reasonable, and I'm going to make the animation progress bar visible again. And back in our graph, when we do our modify name value, if we are changing the background, what's happening is we are assuming it's going to be from a texture. So we are checking to see if our background's primary assets contains that texture, and then we set brush from texture on our background image. But that's not going to work when we're switching to a 3D background because we need to set from material. So we can't just drag off this texture here and do a select. That won't work in this case. So what we're going to do instead is every time we would set our brush from texture, we are going to have to set brush just in general. And then we would have to break this brush, and in the in-brush image, we are going to do a select. And that select is going to be based on if our cast to texture 2D was successful or not. Because if it was not successful, in other words this is null, then that means our name value doesn't correlate with a 2D background, and we're assuming that it is a 3D background. So in the true pin, we are going to pass in our as texture 2D, and if it is false, we are going to have to get our game mode, cast to VN game mode, and then as a VN game mode, we are going to get the VN scene captures. Then we have to find the name value we passed in, which is going to be our background name. And then this find returns a VN Scene Capture 2D object reference, and what we need is its material. So back in our VN Scene Capture 2D, after we create this dynamic material instance, we need to promote it to a variable. And the variable name is just going to be, let's go with material. So back in our dialog, off of this find, we are going to get material. And then we can pass this material into the false. So basically now anytime you would do a set brush from texture, you would have to replace it with a regular set brush and then pass in this select into the in brush image. So our graph now looks something like this. So let's modify our dialog a bit so we can actually view a 3D scene. And this is what we end up with. We start off by saying this is a test of our 3D backgrounds. Then we ask where do you want to go. Our first option is the fantasy forest, which is a 2D scene. And then our second option and third option are left view and right view. And the reason I'm using these select nodes into the speech node is because you can't actually connect into a speech node twice. So if we have a speech node here and we try to connect to this again, it's not going to let us do this because we already have a connection between this node. So that's why there are these select nodes over here in between this node and this node. Anyways, the left view selector has a enter event that modifies the name of our widget's show background, and the name value is a left view. And this name value is just what we put in our background name in our VN Scene Capture 2D, so make sure this lines up exactly. The same applies for our right view, which just does the same thing except the name value is right view. And then this node and this node both lead back to where do you want to go, so we can loop through this and make sure that it works properly. So if we were to play and go to our fantasy forest, we still go to our fantasy forest just fine, and if we go to left view, we now go to the left view, and if we go to the right view, we now go to the right view, and we can go back to our fantasy forest, and it seems to be working just fine. I added another cube in the background, by the way, just to show that our image is updating. So if we were to go to our right view, you'll see that our cube in the background is rotating. If we go to left view, it's still rotating. So let's make sure this works with a animation. I'm going to choose our wipe right. So what our wipe right does right now is it sets the background image to our background image's brush image. So that's still fine because our brush image is just an object reference. It's not necessarily a texture. So even if we're using a material as our background, in other words, we're using a 3D background, this will still work fine. However, if we're using a 3D background, our widget style fill image is still being set from our cast to texture 2D. And instead we need to plug in our select that we made over here. So now that we've plugged in the right one to our widget style fill image, we move on and we say set our background image brush from texture, which is getting our image again from our cast to texture 2D. And in order to set our brush's image, we need to set a brush instead. So let's just copy this, paste it over here for now, and plug in our return value into our brush image so we don't have to drag it down there later. Drag this down over here and connect our set to this set brush instead, and this connects to our play animation. So let's get rid of this. And now if we change the transitions in our test dialog from show background to wipe right, and we hit play and we go to our fantasy forest, it still swipes okay. If we go to our left view, it swipes in. If we go to our right view, that also swipes in, and yeah, it's all swiping in just fine. Go back to our fantasy forest, that still works. Now we have to take care of one last issue, and that is optimization. Now, you might be thinking, optimization in a visual novel, what the heck are you talking about? Well, using these render targets is not cheap. If we were to pay attention to our FPS on the top corner, you'll see that we have an FPS of around 110-ish. If we were to hit play, you'll see that our FPS drops down to 60 FPS. And you might think that that is just the engine sort of limiting your FPS to sort of cap it at 60, but that's not what's happening here. If we were to stop and then just create a ton of more render targets, and then we hit play, you'll see that our FPS drops down to 20 FPS, and that is obviously not very good. So what's happening here? Well, our Scene Capture 2Ds, what's happening is, well, first off, they're getting the image of what they see. In the grand scheme of things, that in itself is not too much of a problem. But after that, it has to copy what it sees onto a texture target. So it has to write all that data onto an image. So imagine if you were taking a screenshot every single frame for every single one of these cameras. It would reduce your FPS significantly. How do we fix this? Well, you'll see down here in our scene capture, there's a boolean called capture every frame. And if this is true, then every single frame, it's going to update the texture target's image. The simple answer would just to make all of these false. So if I go back to my VN Scene Capture 2D, click on the Scene Capture Component 2D, go down to the Capture Every Frame and uncheck this, compile and save this, go back to our world and click on one of these cameras, you'll see that the Scene Capture Component 2D no longer has the Capture Every Frame checked. So if we were to hit play, you'll see that our FPS is still above 100, which is good. However, if we were to start, go to our right view, you'll see that this cube is no longer rotating. So basically what we want to do is make it so that only the scene captures we are looking at actually update every frame. So to optimize our render targets so that the important ones are the only ones that are updating, well, first we need to define which ones the important ones are. Obviously the one that we're going to be looking at is an important one. However, when we are transitioning from scene to scene, the background image that we used to be looking at is also important because we still want it to be updating while it is transitioning. Otherwise it's going to look like that it stopped while it's transitioning, and that's not going to look very good. So the easiest transition to work with first would be our simple show background, because there is no transition time and there is no animations going on to set our background image. So before we set our brush, we're going to have to tell the last VN Scene Capture 2D to stop updating. So we're gonna have to keep track of that. So anytime we would change our background, off this cast to texture 2D, if this is successful, it's gonna be whether or not we're using a 3D background now. So off of this, we're gonna do a branch. And now we need to keep track of our last VN Scene Capture 2D. So let's make a new variable. This is gonna be our last VN Scene Capture. Let's 2D, why not? And the type is gonna be our VN Scene Capture 2D. And then anytime we change our background, if we are switching to a 2D background, we're gonna set this to be nothing. However, if we are switching to a 3D background, we need to set this to be that VN Scene Capture that we used. So that would be this find over here. Actually, now that I think about it, we don't really need this branch. We can just drag off here and do a select. The index is going to be our success, and our false is going to be our find. So in our show background, before we set our background image as brush, we need to tell the last VN Scene Capture 2D to stop updating. So let's move this stuff over to the right and out of the way a little bit. And before we do our set brush, we are going to get our last VN Scene Capture 2D is valid with the question marks so that we get our execution pins. If it is not valid, we're just going to go back to our set brush like usual because that was a 2D background in the last background. However, if it is valid, we are going to have to get the capturing component from our last VN Scene Capture 2D and set its capture every frame to be false. And then we're going to connect that back into our set brush. After we set our brush, we now have to update our last VN Scene Capture 2D, and then we can plug this back into our set Z order. And after we do that, if we are using a 3D background, we need to tell it to update every frame. So off of our last VN Scene Capture 2D, because we now updated it, if it is valid, the not valid is going to connect to our set Z order, and the is valid is going to drag off here and get the scene capture component, and then set its capture every frame to be true. And then we plug this back into our set Z order. So if we compile and save and play this now after setting our transitions back to show background, we go to our fantasy forest, that still works, we go to our left view, and we go to our left view instantly, and the cube is rotating, and you'll see that our FPS is at 80 frames per second, which is not as good as 120, but it's still a lot better than 60 or, well, 20. Go to our right view, and it's still working just fine. And if we were to look at our Scene Capture 2Ds, and we look at our right view and look at its Scene Capture 2D, you will see that it is not capturing every frame. And if we were to look at the left view, look at its Scene Capture 2D, you will see that it is capturing every frame. So that's all good. Now, when we start transitioning, we can't just do this. We can't immediately say set the capture every frame to be false in our Scene Capture 2Ds for our last Scene Capture 2D. Because while we are transitioning, we still want it to be capturing every frame, but we want it to stop after we are done transitioning. So naturally the answer would be to use a delay, but in a function, we can't do a delay. If we try doing a delay, you'll see that only these things pop up. And that is because functions can return a value. And when you are trying to get a value from a function, you obviously don't want to have to wait. You want to get it immediately. So the only times we can actually do a delay is in our event graph. So let's make a new function in our event graph. We will call this something like stop animating last VN Scene Capture 2D. I think that's a descriptive enough name for a function, and what this is going to do is just do a delay, and the delay is going to be 0.5 seconds because that's how long each of our animation transitions are. And on complete, we are going to have to set the last VN Scene Capture 2D to be not updating. However, we can't just get it from here, because if we get it from here, then by the time this delay finishes, this will be updated to be our current Scene Capture 2D. So we need to give it an input of a VN Scene Capture 2D, and now that we have this, we can get its Scene Capture 2D, and on complete, we will set the capture every frame to be false. So back in our modified name value, when we do our wipe right, before we set our brush image, we are going to check to see if our last VN Scene Capture 2D is valid or not. If it is not valid, then we will continue to setting our brush like normal. However, if it is valid, then we need to call the stop animating last VN scene capture 2D. The scene capture, of course, is our last scene capture, and then we're going to go back to setting our stuff like normal. And once again, after we set our background images brush, we are going to have to do this stuff over here. So let's just copy this and paste it underneath here for now, just so we can have easier access to the stuff we need to drag off of. This index is our success, and our false is our find value for our scene captures. So let's drag these down to where they need to go. And now after we set our brush, so let's move this back a little bit, we are going to plug into our set. This is not valid, it's going to plug into our play animation, and our set is going to plug into our play animation as well. So let's compile, save, and play this to see if it works. So if we go to our fantasy forest, you'll see that it swipes like normal, so that's good. And then if we go to our left view, you will see that our left view is clearly updating every frame. If we were to look at that closer to make sure, go to our scene capture component 2D, and there it is, capture every frame is true. Now if we go to our right view, pay attention to this capture every frame boolean over here, you'll see that it sticks around for half a second and then it turned into false. So when it was done transitioning, this turned false. And if we look at our right view, you'll see that our capture every frame is true. And now if we go to our fantasy forest, you'll see the same thing happens. It sticks around as true for half a second and then it turned false. So that's all working good, and our FPS is still around 90 to 100-ish. Well, except for when we're transitioning, because then it has a dip because it's capturing two of them at the same time. But, you know, it's for half a second. It's not that big of a deal. And if it is that big a deal, you can just lower the resolution of your render targets. So if we were to make this something like 16 by 9, which is going to look atrocious, and hit play, start, you'll see that our FPS is over 100. Go to our left view, it's still over 100. Even while we're transitioning, it's still over 100 because, well, it's 16 by 9 resolution. It doesn't really affect our FPS that much at all. Obviously, 16 by 9 is not going to look very good. You could make it 720p if you want, but the obvious best solution is just to give the player an option to choose which resolution they want. But I'm just gonna hard code this as 1920 by 1080 because I don't actually remember what 720p resolution is. Now there is actually one last thing I want to mention before we end this video, and we're not actually going to be implementing it because I don't remember how I did it correctly the first time, but it's something to keep in mind if you can figure it out for yourself. What you can do is once you're done transitioning, instead of continuing to view that render target and having it update, we can just view from this camera. There's no point in continuing to update our render targets if all we're looking at is that render target. So what you could do is, after you're done transitioning, set your background to be a blank image that is completely transparent. So now we're not looking at anything as our background image. And then view from this camera instead. So we would still see the same thing. Actually, it would be slightly different because of the post-processing stuff, but you can deal with that. And that way no scene captures are going to be updating every frame, which will obviously help with performance. And in case you're wondering how we can actually view from that camera, it would be something like this. We would get our player controller, and then off of this player controller, we would set view target with blend. And the new view target here is just the scene capture that we would be looking at through. And our blend time would be 0 because we want it to be instant. But like I said, I don't remember how I got it to work correctly because there is some caveats to doing this when you are working with your delays and stuff like that. So instead I'm just going to make a note of that. And if you figure it out for yourself, please leave a comment below for anyone else that was wondering how to do it. Anyways, that'll be it for this video. I hoped it helped and that this giant mess of notes here wasn't too confusing for you, and that you were able to follow along. And that I will see you in the next video.